Okay, Unit 5, AV1, Lesson 1. We're going to talk area. We're going to develop the formulas for rectangle and parallelogram and apply area formulas to solve some problems. I got a couple puzzles in here that I'm kind of excited about. Yeah, it's pretty fun. Area is fun. Yeah. How many people want to grow up and install carpet for a living? You do? Yes. Now we're talking area, right? Square footage. How many people want to maybe be in construction? Interior design? Ooh, yeah. Oh, surface area. Drapes. Yeah. I got to cover a certain amount of window space. How many people want to paint? Okay. Claire wants to paint? Okay, square footage. We're talking square footage, right? What else would require square footage? How many people come from a farming family? Yeah, Gabe, 23, came from a farming family. Kylie, farming family, right? You got to spread fertilizer, and fertilizer covers the ground, and the ground covers a certain amount of area. Oh, because I don't want to waste money on fertilizer, then it'll take away from the amount I get back after we harvest, right? Okay, it's all money in, money out. Area is involved in everything. Okay, let's continue. All right, so area is a pretty basic concept, right? If I'm talking about a rectangle or a square, I just take the base and the height and I multiply them together, right? Based on those units, right? It might be square feet, square inches, square centimeters, doesn't matter what the unit of measure is. I just take base and height and I multiply them together. Well, it could be length times width, right? You could consider base and height, length and width if you want to. Now, we're going to talk depth later, which will be volume, right? Then it's a third dimension. Then we're sticking a bunch of cubes in here and trying to figure out how many of those fit. But if we're just talking length times width, or area, you could call this width if you wanted to, Lisa, and you could call this length. Really, it's just a horizontal dimension times a vertical dimension. That's it. Cool. All right. So I want for you and a neighbor, I want you to struggle with this problem for a little bit. Okay, I give you a little bit of information. And this is, I'm jumping into R3 land right away, just because I think that area is a topic that is pretty well understood. I give you a couple of lengths. I give you a 3 here and a 3 here and a 9 there. And then I give you a couple or 3 areas. And I want you to find this leftover length here. I want you to talk to a neighbor for, I don't know, 3 or 4 minutes. See if you can come up with a way to figure out what this remaining distance would be up here. Okay, ready? And go. Okay. Okay, add those two together. Too many times I observe a student try to just jump straight to the last piece, right? And it never works that way, right? It's never like, oh, I'm just going to look here, I'll have a number and another number, and I'll be able to figure that out. It never works that way, right? But I am given some information here. I'm given that this side of 3 and this side of something I don't know multiplied to 12. Well, then that makes that side have to equal 4. Are you with me so far? Okay, so I know that this length is 3. So I know this length right here is 3. And this length right here is 3. So the total of those two has to be 6. And 6 and some number, which I've put in purple here, 6 and some number have to multiply to 18. Okay, so that's 6 and 3. So now I know that this purple length right here is 3. So how would I find, let's go with some distinguishable color, which is relatively gross. Oh, well, let's go orange. How would I find that length? Because that length is going to help, right? Yeah, cool. 9. Yeah, I take the 4 and the 3 that I've found. I subtract 4 plus 3, right, which is 7, and I get 2. Okay, so this side is 2, and I know that that times this thing, the whole length, so 2 times, let's call it x, has to equal 20. So x has to equal 10, but is this 10? No, that's going to be 10 minus whatever this is. Well, and I know that length is 6. So I get 4 inches. These puzzles are awesome. They require some reasoning, not just base times height, length times width. Right? You got to understand it, right? Because area can work backwards. I could give you the area in one of the dimensions, and you got to divide to get the other dimension. So it's not just multiplying 2 numbers together. All right, so let's talk parallelogram. Right now, it's no longer right angles. Now the height, or the what you could call the width, right? Let's call this base the length, and this height the width. We cannot, and please don't do this, you cannot use this as your height. What is the relationship that has to be true between your base and your height, or your length and your width? I mean, yeah, they have to form a 90, right? Because the height, the true height, is perpendicular to whatever the base is. So we're still going to use the same formula. Area will equal base times height, but it's identifying what your height is. So on the next page, there's a bunch of problems. We're not going to get all the problems done today, but I do want to talk about not being deceived. Could I deceive you on number 1? Is it possible for me to deceive you on what base and height are? No, because there's only 2 values, right? So it's going to be 7.7 times 2, right? Base and height are actually interchangeable, but the area, you know, is going to be what it is. Okay, here I'd take 5.9 times 4. Okay, well, that's that, right? Remember, area's units are different than the units of base and height. Now, this third one down here in Arizona, this is where you could get tricked. Right? What would you use as the base? You. 15-year-old you. 16, 17, 23, whatever you are. What would you use as the base? 6? Okay. I like that. Okay. Now comes the decision. What do I use as the height? Do I use 5.8 or do I use 5? Right, I'd use 5. So I get an area of 30 square meters. Now remember, area is meters squared. Why? Because you're taking 2 things, you're multiplying together. So you're getting a measurement times a measurement. So meters times meters is meters squared. Okay, and the third one, I can't really fool you there, but typically, you know, a kid will say, well, the base is 15.2 because it's flat, right? It's parallel to the ground. Well, your math won't come out any differently, but technically your base is 20, and your height would be that 15.2. And of course, you could use your calculator to find the area. Okay. All right. Let's pause this for a second. Okay. Now let's look where we have a little bit more complicated situation. In this problem on the left side, I haven't given you the height, but I have given you the area and the base. So what should we do with the area and the base? Divide them, right? If area equals base times height, of course, if this is what I'm looking for, that's easy. I'm just going to multiply it, but I'm not. I'm looking for, in this case, the height. So I want to isolate the height. So to isolate the height, I divide by the base. So height equals area divided by base. So 96 divided by 12. Well, that should be a nice whole number, and it is. It's 8. That height should be 8 inches. What do I do if there's 2 shapes that are combined? Oh, gosh. Well, just find the area of both of them and do what with them? Yeah, add them together. Too easy. That's too easy. Let's add them up. So I'm just going to separate it this way. If you wanted to, you could separate it this way as well and find 3 areas and add them up. The dimensions of this one will be 13. What will this dimension here be? What's the distance from there to there? Yep, Sean? 14, yeah, take the 25 minus the 11. We're going to assume that all of these are either rectangles or squares, right? We won't assume that that's a parallelogram of any sort. So I take 13 times 14 to get this area, right? Whatever that is, I don't know. Then over here, I take 11 times 13, and I get a number. 11 times 13, I get a number. And then up here, I take 11 times, what's that going to be times? 12? Does that look right? Yeah, because I'm going to take this 25 right here and subtract away a 13 right here, and that'll give me a 12 for that length right there. Okay, and I'd take those three values and I'd add them up. Too easy. Yeah, cool. You folks out there that said you didn't want to do any painting, anybody want to do drywall? Actually, that pays pretty good. Drywall, anybody? No? Okay, well, what if I wanted to drywall my basement, which is very boring looking, isn't it? It's got a door. That's it. Okay, well, I'm not going to drywall the door, so I have to count for that, right? I don't want to waste money on that. Just paying Home Depot a little extra, just for the heck of it. I'm not marketing Home Depot. Those of you who go to Menards, it's okay. Or Lowe's. Okay, so how would I do that? Do I drywall the floor? No. For those of you who don't know, you don't drywall the floor. You don't. You don't. Okay, so I just want drywall on the walls. I don't want it on the door. So I can find some surface areas, right? Let's just talk through this real quick, and then we'll be done for the day. And you can try that. What would this be? Oh, that's a terrible color. What would this be? 8. Let's assume that my carpenter, whoever built my house, was cool with math and made all heights 8. Okay. Everybody okay with that? Cool. All right. And does this look just off to you? It looks a little off to me. Okay, what would this length be? 18, right? That would happen here and here and here as well. All right, and then, ooh, this is going to get kind of ugly, I think. We'll see. And then this should be 12 everywhere. So I would want to find the surface area of each of those walls, which are all just rectangles, except one of them you take away the door, right? You take away the door. And then I'd add all those up. And I'd say, okay, what size are the sheets at Home Depot? Oh, well, they're 4 by 8. Perfect. My ceiling height is 8. Perfect. Right? So I could just have a bunch of sheets of drywall that just boom, 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 boom. Okay, but 4 doesn't go into 18 evenly, so I'd have half of one at the end, right? Okay, so I'm planning ahead. I'd probably use that other half over here, and then boom, 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 right? So I've counted for the walls. Okay, now I'm going to count for this wall here. I'm not doing this to scale, but do you understand what I'm trying to tell you? Right? If you're painting, oh, much easier. A gallon of paint covers this many square feet. Well, find out how many square feet you have, and then probably a little extra, because your kid's going to walk over and take their fist and dunk it in there and take, because that's just how it works. Or your dog will slap the paint can over, and you'll have to recarpet after you're done painting. No? Okay. Okay, so that's the lesson for today.